Welcome to the Mega-Shipyard. Today I'll show you how a massive offshore oil rig is made, step by step.
These colossal structures are marvels of modern engineering, designed to withstand the harshest ocean environments. An offshore oil rig is essentially a floating city, but before it reaches the ocean, it begins here, as basic raw materials. Every single component is meticulously planned, using advanced 3D CAD software to ensure absolute precision. From the submerged pontoons to the towering drilling derrick, every section must be flawless. Let's dive into the first phase of this immense construction journey, gathering and preparing our raw materials. The journey begins with raw iron ore and metallurgical coal arriving at the coastal steel mill. These raw ingredients are fed into a blast furnace, heated to over 2,000 degrees Celsius. The intense heat melts the iron, separating impurities to create liquid pig iron, the foundation of our steel. To survive the corrosive seawater, the rig requires specialized, high-strength, marine-grade steel. We add specific alloys like chromium, molybdenum, and nickel to give the steel incredible tensile strength and rust resistance.
The molten mixture is cast into enormous, glowing slabs that will form the backbone of the rig. Massive hydraulic rollers compress these slabs, thinning them out into dense steel plates.
High-pressure water jets blast away surface oxidation, ensuring the steel is pure and perfectly smooth.
Once cooled, these marine-grade plates are ready to be transformed into the structural components of the rig.
Trains and heavy transporters deliver thousands of tons of this specialized steel directly to our fabrication yards. Here, materials are sorted and cataloged. Every piece of steel is tracked with a unique digital barcode.
Traceability is critical. If a piece of steel fails decades from now, we know exactly where it was made.
With our materials secured, it is time to shape them. We move into the primary processing phase.
Giant magnetic cranes lift these colossal plates, feeding them into the automated cutting machines.
Inside the fabrication hall, CNC plasma and laser cutters slice through the thick steel with pinpoint accuracy.
These automated machines follow the 3D blueprints perfectly, creating the complex geometries needed for the hull.
Once cut, the flat plates often need to become cylinders to form the rig's massive buoyancy pontoons and structural legs. Heavy-duty plate rollers apply thousands of tons of hydraulic pressure, slowly curving the unyielding steel.
The edges are brought together to form massive tubular sections, known as cans, which will be stacked later. An automated submerged arc welder fuses the seam. This process creates a weld that is often stronger than the steel itself.
For the joints where multiple legs connect, we need cast or forged steel nodes that can handle immense stress.
Hydraulic forging hammers pound the hot steel, aligning the grain structure to maximize durability and strength.
These nodes are the critical junctions of the rig's framework, designed to absorb the shock of rogue waves.
Thousands of these tubular sections and nodes are manufactured simultaneously in different wings of the shipyard.
Before assembly, each component must be surface treated. Sandblasting removes any mill scale or rust.
This rough profile provides the perfect surface for our industrial-grade, anti-corrosive marine paint to adhere to.
Multiple layers of specialized epoxy coatings are applied to protect the steel from the merciless salt water. These coatings act as the first line of defense against the ocean, preventing catastrophic rust.
The painted sections pass through thermal curing ovens to harden the coating quickly and efficiently.
Now processed, coated, and cured, the individual building blocks of the oil rig are ready for the next phase.
Self-propelled modular transporters, or SPMTs, carry these massive pieces toward the sub-assembly yards.
Logistics at this scale require military-like precision.
The right part must arrive at the right bay at the exact right time.
Waiting for them are the Goliath cranes, capable of lifting up to 20,000 tons of steel. With all our components processed, we are finally ready to begin the core production and transformation. In the core production phase, we begin joining the smaller sections into massive structural blocks. Every weld is critical. A single weak point could compromise the entire rig under the stress of a hurricane. This modular construction method allows us to build the rig in separate, manageable blocks. Where welding isn't used, high-tension structural bolts lock the heavy framework together.
Here we see the completion of a lower pontoon. These giant hollow structures will provide the rig's buoyancy. Inside the pontoons, a complex web of steel bulkheads ensures structural integrity against crushing water pressure.
Next, the massive vertical support columns are welded directly onto the buoyancy pontoons.
These columns will support the main deck, keeping the crew and machinery safely above the highest ocean waves.
Before the columns are sealed, kilometers of electrical wiring and piping are meticulously installed inside them.
The complexity is staggering. The lower hull alone contains enough steel to build 2 Eiffel Towers.
While the lower hull takes shape in the dry dock, the topside facilities are built simultaneously on land. The topside includes the living quarters, a multi-story hotel that will house up to 200 offshore workers. These modules are fully outfitted with galleys, recreation rooms, and medical bays right here in the shipyard.
Nearby, the processing modules take shape. This is where the extracted oil and gas will be separated and treated.
Heavy machinery, like gas compressors and power generators, are installed into these modules early in the process.
The crown jewel of the topside is the drilling derrick, the towering structure that handles the miles of drill pipe.
The derrick is equipped with a top drive motor and a massive hook capable of lifting over 1 million pounds.
At the very top, a lightweight but incredibly strong aluminum helideck is constructed for crew transport. We now have a lower hull sitting in the dry dock, and thousands of tons of topside modules waiting on land.
The core production phase is complete. It is time for the most dangerous and visually spectacular phase, the final assembly.
To assemble these gigantic pieces, we rely on the largest lifting machines ever created by humanity.
Thousands of tons of delicate processing equipment are lifted high into the air with millimeter precision.
All right, bring her left 10 feet, easy now.
Roger, moving left.
Looking good, coming down slow.
The modules are lowered onto the support columns. The structural pins must align flawlessly to lock everything in place. Once seated, specialized welding teams work around the clock to permanently fuse the topside to the hull. The piping networks are married up, ensuring seamless flow of fluids and gases throughout the rig.
With the physical structure connected, miles of electrical, hydraulic, and data cables must be tied together. Finally, the towering drilling derrick is installed, completing the iconic silhouette of the offshore oil rig. Standing taller than a skyscraper and weighing tens of thousands of tons, the assembly is finally complete. But the work isn't done. We move into the outfitting and commissioning phase, turning this steel island into a living machine.
The central nervous system of the rig is installed, featuring state-of-the-art automation and safety computer networks.
The driller's cabin is outfitted with cybernetic chairs, allowing operators to control massive drill pipes with simple joysticks. Deep inside the hull, massive marine diesel engines are primed and tested. The rig must generate its own electricity.
Thousands of gallons of hydraulic fluids and lubricants are pumped in to bring the heavy machinery to life. Safety is paramount. The specialized free-fall lifeboats are installed and rigorously tested. Advanced fire suppression systems, including foam cannons and water deluges, are fitted across the entire topside.
The blowout preventer, a critical safety valve stack weighing hundreds of tons, is inspected and prepped for deployment.
The mud tanks are finalized. These will hold the heavy drilling fluids required to control pressure inside the well.
For mooring, anchor chains with links the size of a human torso are loaded onto the rig's powerful winches. The rig is stocked with months' worth of spare parts, tools, and operational supplies.
The galleys are provisioned. The crew will need thousands of high-calorie meals during their tough offshore rotations. Aviation fuel tanks are filled, and the helideck receives its final certification with a test landing. Finally, the main power is switched on. The rig transitions from a cold steel structure to a living, breathing facility.
Illuminated against the night sky, the platform is fully powered and ready for the most rigorous inspections on Earth.
Before this billion-dollar asset can be handed over, it must pass a grueling series of quality control checks.
Every single pipe and pressure vessel is hydro-tested to ensure there are zero leaks under extreme pressure.
Inspectors use ultrasonic and X-ray technology to peer deep inside the structural welds, hunting for microscopic flaws. The generators are pushed to their absolute maximum in a severe load test to ensure they won't fail during a crisis. Once every system passes certification, the rig is officially commissioned. It is time for it to meet the ocean.
The distribution phase begins with the flooding of the dry dock. Millions of gallons of seawater rush in. For the first time, the massive steel pontoons feel the buoyant force of the ocean.
As the dock fills, the colossal structure gently floats, proving its watertight integrity and perfect balance.
An armada of heavy ocean-going tugboats attaches tow lines. Navigating this behemoth out of the harbor is a delicate operation. Slowly, the rig leaves the Mega-Shipyard behind, beginning its journey to the offshore oil field miles away.
The tow-out can take days or even weeks, depending on the destination, creeping along at just a few knots.
The immense drag of the submerged pontoons requires immense pulling power from the specialized tug fleet. For the skeleton crew on board during transit, it is a quiet wait before the intense work of installation begins. Upon reaching the designated offshore oil field, the delicate installation process commences.
The rig's own powerful winches tension the chains, locking the floating platform tightly against the ocean currents. The ballast control operator fine-tunes the rig's draft by pumping water in or out of the submerged pontoons.
Supply vessels and heavy-lift ships arrive to assist in the final hookup and commissioning of the drill floor.
Thousands of feet of heavy drill pipe are loaded into the automated pipe handling systems on board.
The rig is now positioned directly over the subsea wellhead, thousands of feet below the surface. The drill crew, known as roughnecks, prepare the massive diamond-studded drill bit for its long journey down. The bit is lowered through the ocean, guided by subsea robots, until it reaches the ocean floor. Fully moored, fully powered, and actively drilling, the rig has transformed from raw steel into a marvel of energy production. It is now a self-sustaining island, capable of operating safely in some of the most hostile environments on the planet.
Every system, from the drilling motors to the safety flares, operates in perfect harmony.
A constant lifeline of supply ships keeps the rig fueled, fed, and running 24 hours a day, 7 days a week.
The crew works grueling 12-hour shifts, maintaining absolute vigilance over the highly pressurized systems below.
Built with tens of thousands of tons of steel, it flexes and rides the waves, shrugging off the fury of ocean storms.
It stands as a testament to human ingenuity, pushing the boundaries of engineering to extract energy from the deep.